All right, so I'm going to work out the solution to problem number 2B now, 2B. This is a problem where in 2A, I think you were supposed to find the maximum acceleration. I'm actually going to do that for you in this one. But for this problem, the maximum acceleration is important to know. All right, so we want to find the maximum force on a mass in an oscillating mass spring system. The problem tells us some certain information. First of all, it tells us what the mass is. Now, 5 grams is not the unit we want. Grams, of course, we want it in kilograms. We'll convert that later. We know that the amplitude of the mass spring system is 1 centimeter. Also, not the unit we want. We want it in meters. We'll convert that later. And they tell us the period is 0.040 seconds. So we need to find the maximum force. Now, there are actually 2 equations we could use. We have to choose one of them. The first one is Newton's second law. That's the equation that we learned back in first semester, where the maximum force is going to be the mass times the maximum acceleration. That's one option. The other option is to use our new equation for force, Hooke's law, that says that the maximum force is equal to negative k, the spring constant, times the maximum displacement. Now, a couple things to remember. First of all, the maximum displacement, of course, is the amplitude. That's how amplitude is defined. Maximum displacement is the amplitude. And we know the amplitude. Also, remember that that negative sign is only there for direction. It tells us that the force and the displacement are in opposite directions. So we can either use F max equals m times the maximum acceleration, or F max equals negative k, the spring constant, times the amplitude. It all depends on what we know in the problem. We know m and a, the amplitude, and the period. So now you might look at these 2 equations, you might say, well, it seems like we know half of what we need to know for either equation. We know the amplitude, but we don't know k. We know the mass, but we don't know the acceleration. So you kind of got to sort through, how do I want to solve this problem? Which of these equations do I want to use based on what I know and what I don't know? My recommendation would be, what seems most comfortable to me is this. I know that the maximum acceleration is equal to this. This should be one of the equations. A max equals 4 pi squared f squared a. That should be one of the equations you've got in that toolbox of equations that we were keeping track of on the board at school, and that you should absolutely have at your disposal when we are doing an assessment this Friday and next Monday. A max equals 4 pi squared f squared a, where the f is, this f is lowercase f, the frequency, and this, of course, is the amplitude. So what do we know here? Well, we know the amplitude. We've got to convert it, but we know it. We know the frequency. Now, you might say, well, we don't know the frequency, Mr. Morgan, but we really do, because remember, we know the period, and the frequency is just the reciprocal of the period. So when I plug in the period to this equation, I get 1 divided by 0.040, and I get 25 hertz for my frequency. And once I know that, I can plug that in to my acceleration equation. And then remember, my amplitude is 1 centimeter, but I need to convert that to meters. So I divide by 100, and I get 0.01 meters. So now I'm going to multiply all that out. 4 times pi, I'll use 3.14 squared, times 25 squared, times 0.01 equals, and I get what you should have gotten if you did part A correctly, 246 meters per second squared. That's the maximum acceleration of this system. Now, what that tells us is this value right here. And since we know the mass, this value right here, we can now use this equation, Newton's second law, to find the maximum force. So I've got F max equals 5 grams. Again, you've got to convert to kilograms. So divide by 1,000, 0.005 times 246. And again, I got to get out the calculator. Times 0.005, and I get 1.23 newtons. And that is the maximum force for this particular mass spring system.